Hello students, today we are going to summarize the work which had been done within week 2. We will cover lesson 10.3 volume of a sphere and lesson 10.4 finding missing dimensions. By the end of this session you must be able to find volume of a sphere, find volume of hemisphere, apply volume of a sphere in real life problems, find missing dimensions of cylinder, cone and sphere. We will cover selected exercises from your book, page 557. Exercise number 1, find the volume of each sphere. Express your answer in terms of pi. I have to look at the question and figure out what is given. What is given here in this figure, in this sphere? The given here is r, which is radius of the sphere, equal 23 feet. The question asks you to find volume of a sphere, so directly go down and write formula of volume of a sphere, which is 4/3 pi r cubed. The question asks you to express your answer in terms of pi, so we will keep pi and substitute by r equal 23 cubed. 23 cubed means 23 times 23 times 23, repeated 3 times, which is 12,167. So the volume equals 4/3 times pi times 12,167. We will multiply 4 by 12,167. We will get 48,668/3 pi. Don't forget that we will always keep the pi. The question asks you to keep it, to express your answer in terms of pi. So the answer will be 16,222 and 2/3 pi cubic feet, or you can write it as a decimal, 16,222.6 pi cubic feet. Let's go to exercise 2 to cover other idea. Find the volume of each sphere. Express your answer in terms of pi also. What is given here? Look at the given. The given here is D. It's the diameter. And the given here is D, diameter. Diameter of a sphere equals 2 double the radius. Another way we can say that if you want to find the radius, it will be diameter divided by 2. So radius here equal 9 divided by 2 equal 4.5 inches. And the question asks you to find volume of a sphere. So write down the formula of volume of a sphere, 4/3 pi r cubed, and substitute by r equal 4.5. It will be 4.5 cubed. And multiply 4 by 4.5 cubed. And don't forget to keep the pi always. The answer will be 121.5 pi cubic inch. We will keep the pi because the question asks you to express your answer in terms of pi. And now we will go to apply volume of a sphere in real life problem. This is exercise 4. The radius of a mini basketball is 4 inches. A pump can inflate the ball at a rate of 60 cubic inches per second. How long will it take to inflate the ball? Round your answer to nearest 10th. Let's try to figure out, let's try to find any key answer here. The radius of a mini basketball is 4 inches. So in this question, what is given? R. The given is R. And R equals 4 inches. What else is given? It's mini basketball. Mini basketball means a sphere. So the question, sorry, the question is about volume of a sphere. And one more keyword. Look here, a pump can inflate the ball at a rate of 6 cubic inches. And cubic inches is a keyword for volume. Cubic inches means volume. It's keyword for volume. So the question is about volume of sphere. Okay, so I have to go and write down directly formula of volume of a sphere, which is 4/3 pi r cubed. And we already got the r, which is 4 cubed. And here we will substitute by pi equal 3.14. Why, teacher? Because the question asks you to round your answer to nearest 10. So the volume will be 267.94. And the question asks you to round to nearest 10th. So I'll go to the 10th and arrow to the digit to the right of the 10th. It's 4. 4 is less than 5. So I just cancel it and keep the 10th. The volume of the mini basketball will be approximately equal to 267.9 cubic inch. We are done step 1, which is volume of ball. And let's read the question again. The radius of a mini basketball is 4 inches. A pump can inflate the ball at a rate of 6 cubic inches. Oh, once I see the word rate, it means that I have to write a proportional relationship. The rate here is 6 cubic inches per second. So the rate points to 6 inches per second. And the question asks you about how long will it take to inflate the whole ball. So I'll explain this point. If 6 cubic inches need 1 second to be inflated, so the whole volume of ball, which is 267.9 cubic inches, need how many seconds to be inflated? This is the question. So step 2, I'll go to write a proportional relationship. I'll use equivalent ratios to solve the proportion. The proportional relationship or the rate which is given is 6 cubic inches per 1 second. This is which is given in the question. And of course, the volume of the ball is 267.9 cubic inches. It will go to the numerator because in the proportional relationship, I have to keep the same unit in the same side of the fraction. So 60 cubic inches for numerator. So I have to put 276.9 cubic inches numerator also. And down 1 second, 6 cubic inches per 1 second. So in the denominator also second. And this is the question. This is what is required to find. We need to find how many seconds to inflate the ball. This is the question, and this is what does X mean? Number of seconds which needed to inflate the ball. So I'll consider the number of seconds needed to be inflate the ball, X, and I'll apply cross multiplication. So 6 inches times X, it will be 6 and 6X, and multiply 276.9 times 1, and 6x equals 276.9. I want to isolate the x. I want to get rid of the x, so we will divide both sides by 6. So x equals 44.65, and I need to round to the nearest tenth. So I'll underline the 10. Look at the digit to the right, which is 5. 5 is exactly equal 5, so I'll add 1 to the 10. The number of seconds needed to inflate the ball is approximately equal to 44.7 seconds. Let's go to exercise 6. Exercise 6, it's about volume of hemisphere. Exercise 6 is about volume of hemisphere. And of course, you know that volume of hemisphere is the formula of volume of hemisphere is 2 over 3 pi r cubed. Let's read the question. Find the volume of hemisphere round to nearest 10. And what is given here, teacher? The given here is r, radius of hemisphere, equal 12 millimeter. I'll write the formula and then substitute by pi equal 3.14. Why miss? Because it asks you to round to nearest tenth times 12 cubed. 12 cubed equal 1,728. And here you can simplify. Divide by 3 equal 1. Divide by 3 equal 576. So the volume of this hemisphere is 3,617.28, and we need to round to nearest 10. So I look to the digit to the right, it's 8. It is more than 5. So I'll add 1 to the 2, it will be 3. So volume of hemisphere is approximately equal to 3,617.3 cubic millimeter. And now we will go to apply volume of sphere in multi-step real life problem. And this is exercise 9. Exercise 9. Miguel has a ball of a modeling clay that has a diameter of 3.5 centimeters. The cylindrical container it is placed in has a base area of 7.1 square centimeters and a height of 5 centimeters. What is the volume of empty space in the container around an Argentinian stand? Here, we have to follow specific steps. We need to find the volume of empty space. So first of all, always in such questions, find the volume of container, and then find the volume of objects which are inside the container. And third step, you will subtract volume of the container minus volume of what is inside the container. So I read the question again to figure out what is given. Miguel has a ball of modeling clay that has a diameter of 3.5. So this is diameter of the modeling clay which inside cylindrical container which has base area of 7.1. So base area of container equals 7.1 square centimeter, and its height equals 5 centimeter. So which formula for cylinder I'm going to use? I'll use volume of cylinder equal base area times height. Why, teacher? Because radius is not given. So volume of container, which is cylinder, equals 7.1 times 5 equal 35.5 cubic centimeter. And we will go to find volume of the object which inside volume of the object which inside the container, which is volume of the ball. Volume of the ball, the formula is 4 over 3 pi r cubed. Okay, and what is given here about the ball? The given here is radius of the ball. The given here is diameter, d equal 3.5 centimeter. So I need to find r. R equals D divided by 2, which is D divided by 2, which is 3.5 divided by 2 equals 1.75 centimeter. So I'll go to substitute directly in the formula of volume of ball. It will be 4 over 3 times 3.14 times 1.75 cubed equals 22.4 cubic centimeter. This is volume of the ball which inside the container. And the third step that we need to find the volume of the empty space, which means volume of the container minus volume of the objects or object which inside. So it's volume of cylinder minus volume of ball, 3.35. 0.5 minus 22.4 equals 13.1 cubic centimeter. This is volume of empty space inside the cylindrical container. And now we will move to lesson 10.4, which is finding missing dimensions. And we will go directly to exercise 1. The volume of cylinder is 72 pi cubic feet and the radius is 6 feet. What is the height of the cylinder? As you know, when the question asks you to find the height or whatever missing cylinder, whatever missing dimensions, we have to write the formula. It's volume of cylinder, which is pi r squared times height, and we go directly and substitute by the given volume instead of the word volume which we wrote in to the left side. So 72 pi equals pi times 6 squared, which is radius of the given cylinder times height. 6 squared is 36 and we need to isolate h. So we will divide both sides by 36 pi. So we'll cancel 36 pi. So height equals 2 feet. One more exercise. The volume of a cylinder is 5070 pi cubic centimeter. So it points to volume of cylinder. I'll go directly and write volume of cylinder formula, which is V cylinder equal pi r squared times h. And what is given here? The given here is h equal 30 centimeter. And directly, I go to substitute by the given volume, which is 5070 pi, instead of volume in the left side equals pi times r squared times 30. I substitute by h, and I want to isolate the r squared 30. You can divide both sides by pi to get 5070 equal 30 r squared, and I want to isolate the I squared, so I divide both sides by 30. So r squared equals 169, and to get r, we need to take a square root of both sides. So r equal 13, so radius equal 13 centimeters. Let's go to exercise number 4. The volume of a cone is 735 pi. So directly go and write formula of volume of cone. And what is given? The given is height of the cone, which is 5 millimeter. And I read again, the volume of a cone is 735 pi. So I'll take this given volume and substitute instead of the word volume to the left. So 735 pi equals 1 over 3 pi r squared times 5. And I'll multiply, to make it easier to solve, I'll multiply 5 by 1. So it will be 735 pi equal 5 over 3 pi r square. And you can divide both sides by pi to get rid of pi. It's like canceling pi from both sides. And now we need to isolate the r square. To isolate r square, we need to multiply by the reciprocal of 5 over 3. It means divide by 5 over 3 or multiply by reciprocal of 5 over 3, which is 3 over 5. So multiply both sides by 3 over 5. By 3 over 5, you will get rid of the coefficient of r square, and we will get that 441 equals r squared. And to get r, we need to take a square root of both sides. So r equals 21 millimeter. We will go to exercise 6. It's about volume of a sphere. The volume of a sphere is 4,500 pi. So directly go and write formula of volume of a sphere. What is given here, teacher? It's just volume of a sphere. Why? Because the sphere has only one dimension. It has just r. And the question asks you to find the r, the radius. So substitute by the given volume, which is 4,500 pi. And instead of the word volume of a sphere, equal 4 over 3 pi r cubed. And you can get rid of the pi by dividing both sides by pi. So 4,500 equal 4 over 3 pi r cubed. And we need to isolate just the r cubed. So we will multiply by the reciprocal of the coefficient of r cubed, which is 3 over 4, to get rid of the 4 over 3. And 3 over 4 times 4,500 equals r cubed. And then multiply, you will get 3,375 equal r cubed. And here we need to get r from r cubed. That's why we will apply cubic root to both sides. So we will take cubic root of 3,375 and cubic root of r cubed. Cubic root of 3,375 is 15. Cubic root of r cubed is r, so r equals 15 yard. Don't forget to put the unit, which is given in the head question already. And now we will go to apply finding volume of missing dimension in multi-step real life problem. This apply question, you will find it in your book, page 566. Exercise 9. A party store is placing party hats in the shape of cones on a 6 foot long shelf. If the a party store is placing party hats in the shape of cones on a 6 foot long shelf. If the party hats are lined up in a row, how many more of the smaller party hats will fit on shelf than larger party hats? Listen to this question. I'll explain it before writing the steps. Here we have a shelf, and we need to place the large hats and small hats on this shelf. And we need to figure out how many small hats more than the large hats will be fit on the shelf. To find this, first of all, I want to check the units in this question. A party store is placing party hats in the shape of cones on a 6 foot long shelf. and look at the unit on the given figure. It's inch, inch, and cubic inch. So I need to convert the 6 foot long into inches. And actually, one feet equals 12 inches. And the length of this shelf is 6 foot. So 6 foot equals 6 times 12 equal 72 inches. Why, teacher? Because the given units here, all of the given units in the figure is inches. And I have to give the same unit to the shelf and the figure. And first step, to find number of large hats which can fit the shelf, I need to find the diameter of each hat. Why, teacher? Because the shelf here represents horizontal line. I want to show you this. The shelf is a horizontal. The shelf is a horizontal line, isn't it? And here are the cones. Here are the cones or hats. The hat has two dimensions. It has the diameter and has the height. Which dimension of these is placed on the shelf? Which dimension of these is placed on the shelf? Is it the diameter or height? It's very clear that diameter. So to figure out how many hats can I place on this shelf, I need to find the diameter. How many diameters can fit this shelf, teacher? Okay, it means I need to find diameter of one large hat and divide the length of this shelf by the diameter to get how many hats will fit the shelf. Okay, I think you got it now. Now we will go back and try to find the diameter of a large hat. And to find the diameter, we have to find the radius. So we will go and write directly the formula of volume of cone. And what is given here? The given here is volume of cone. The large cone, its volume is 209.4 cubic inch. So I'll go and substitute, replace the word volume from the left side by the given answer. So 209.4 equal 1 over 3 times 3.14, which is pi, times r squared times height. The given height here is 8 inches. When we multiply 1 over 3 times 3.14 times 8, we will get 8.373 equals 209.4. And I want to isolate the r squared. That's why I divide by 8.373. I'll divide both sides, of course. And when you divide 209.4 by 8.373, you will get 25 equal r squared. But teacher, I want to find the r. So I'll take a square root of both sides. So 5 equal r, or r equal 5, which is radius. And we do need to figure out how many hats can fit the diameter, the shelf, sorry, I need to find the diameter, not radius. And to find the diameter equals 2 times radius always. So D equal 2 times 5 equal 10 inches. Okay, and now we found the diameter of each hat. We need to find how many large hats will fit the shelf. Do you remember when we converted the length of the shelf, which is 6 feet, into inches? We got 72 inches. So now I need to divide the 72 inches by the diameter of the large hats. And we said diameter of large hats is 10. So 72 divided by 10 equals 7.2. And do we have decimal of hat? Can we find 0.2 hat? No, teacher. That's why we will cancel. It's not rounding. It's real life hat. So the maximum number of large hats equals 7 hats. And we need to find also number of small hats. We will follow the same steps. We will write the formula of volume of cone, which is V equal 1 over 3 pi r cubed times h. And the given height for the small hat is 6. So I'll substitute and multiply. The given volume for the small hat is 100.5. So I'll go directly and substitute instead of the word volume in the left side by 100.5 equals 1 over 3 times 3.14 times r squared times 6. All of this will give you 6.28. And teacher, I need to isolate r squared. So I'll divide by the coefficient of r squared, which is 6.28. You must divide both sides, and then we will get rid, of course, of 6.28, and 100.5 divided by 6.28 is 16. So r squared equals 16. Do we need r squared? No, teacher, we need just r. Why? Because we need to find the diameter, and directly D equal 2r equal 2 times 4 equals 8 inches. And now, do you remember this? To find number of small hats on the shelf, we need to divide the length of the shelf again by the diameter of the small hats. So we will divide 72, which is length of the shelf, by 8, number of small hats equals 9. And step 3, always number of small items minus number of large items. So it will be 9 minus 7 equals 2 small hats more than large hats on the shelf. I hope that you got the ideas which we covered today. Thank you very much. And now you have to go back and revise whatever you missed from the steps on your book. Thank you very much.